That was a long introduction that had very little to do with you. But anyway, big welcome to Bryan, who's here to talk to us about testing from the outside in. Thank you for being here.
Can everybody hear me all right? Great. I really appreciate the Ruby meetup existing and being here. I actually recently just got hired because of a connection I made at these Ruby meetups. So I owe you guys a huge debt of gratitude. And I hope everybody who's here tonight keeps coming back and makes the community even better. So as Brent was saying, I am a recent code school graduate. And I was trying to get a job here in the Portland area, and part of that was going to a lot of meetups like this one, and the Mentorship Saturdays meetup, which I'm sure some of you have heard of. And along the way, I started noticing there's a couple of people out there who had similar comments. One person at the Mentorship Saturday meetup asked me to look at their code for a Rails project, and I asked, can I see your tests? And they were like, man, you know, I like the idea of testing, I'm just not sure how to do it. Another person that I met at a Python meetup had just done a PhD, and they had a huge project that's like 2,000, 3,000 lines of code, and I was really interested. I asked to see their tests, and they're like, this project doesn't really need tests because I'm the only one working on it, and I pretty much know how everything works. And I think a couple of those comments are misconceptions about why you would want to test or how to go about doing it. And so I thought I could add some value to the community by explaining my answers to those kinds of comments. And this is going to be a really basic level talk about how and why you'd want to test. So if that doesn't sound like something that applies to you, I hope you can still get some value out of this by thinking about how you would explain these concepts to a new member on your team. Or if you have any suggestions on how I can make this talk better, I'd love to talk to you one-on-one after I'm done. So the title is Testing from the Outside In. I got a lot of ideas from an article on Thoughtbot. But I think to start with, we want to talk about why you would test. And I think all of these are the reasons that I justify using software testing for myself. And some of them are really obvious and some of them are not so obvious. I think we all know that when you write a test for your code, you run the test and it tells you if your code does that thing. That's pretty obvious. On top of that, when you write new code, you run your old tests and it tells you if you broke anything. Great. I think everybody knows that that's a good thing. The next idea is actually what changed the way I write code as a developer. When you write a test, you're giving yourself a really small goal that you can work towards. You're saying, when this test passes, I've finished this piece of code. And for me, a person who gets distracted really easily, dives down a rabbit hole, I used to start coding, and then 2 hours later, I'd run my code for the very first time, and then I'd spend 45 minutes adding semicolons that I forgot. And that's not a good use of your time. And the sooner you can run your test suite, the sooner you know those sort of problems exist, and you can fix them. And you can get back to focusing on the real problem. The next one on this list is a really clever idea that somebody gave me. This was Jeff Casimir at the Turing School. If you write a really comprehensive test suite, another developer can pick up this test suite and read through all of the public methods and functions that your code has. They can see how to format the input to those methods, and they get a little demonstration of what happens, what's the output for those functions. So if you give me a really good test suite, I can sit down in front of your code and figure out how to use it all by myself. So software tests can work as documentation if they're done well. Finally, this one I think is the most surprising to me. Thinking of software tests as a design document was not something that I was doing at all when I started my boot camp. But an instructor named Andrew Karmer was saying, you can actually specify the HTML tag that surrounds this thing. You can specify where on the page it exists and how it looks right at the test step. And that way, you don't get lazy halfway through and say, I'll figure this out later. You actually force yourself to follow that design specification when you're writing your code. All right, so we've got a good idea that testing might be a thing we want to do. The basic mantra of testing is red, green, refactor. And that is a loop that you want to execute in your brain very quickly and very often. You want to go red, green, refactor several times a day or several times an hour as you work. So red means you write a test and it fails. You get a red message on the screen, usually. Green means you've written some code that makes that test pass. And finally, refactoring means you're going to go into the code you've written and change it to make it better. Well, better is an ambiguous word. There's a few ways you can do that. You can refactor to eliminate redundancy. That's a very common thing. You start changing the program so that you don't repeat yourself as often. You can make it more human readable. So if you have short method names, you can expand those so that people can read them. And all along the way, if you change the method name and your test fails, well, now you know that you have more work to do. And the test will guide you along the way and make sure you don't break anything. The way I like to start a test is by imagining what a user is going to do with my application. So I start with a user story with a very strict format. I start by saying, as this type of person, when I want to do this thing, then I expect this result. And this is really beneficial to me because I can go to a person who's going to use my software and say, describe to me how you're going to do this thing. My sister gave me a project that she needed help with, and she thought software was the way to solve this problem. So I just interviewed her for an hour, and I was like, all right, so when you sit down and log in as an administrator, what do you see on the screen? What's available to you? And I wrote down careful notes, and I made stories like the one you see below. As a user with an account, when I click login, I fill in my credentials, then I see the dashboard, and I see a confirmation that I'm logged in. All of that stuff is embodied in this story. And now, when I go to write my test, I leave those comments in my test file as a way to guide me towards that goal, that story that I'm telling about their experience. So I just fill in when as a user with an account. Well, I'm going to need a user, and this is how you create one. When I click login, all right, here's this example of using your test to dictate like the design of your code. I decided I want a nav bar. I want a bar across the top with a login button. It's going to look pretty. So within the nav bar, I want the login button to exist. And when I click it, there's a form that I can fill in. And after I filled in that form, I'm going to see this. I'm going to expect to get redirected to a dashboard. And I expect to see I've logged in as Emil Garbanzo. I don't know who that is. That's random data. So that is like the really basic, how do I write a test? This is what I would describe as a feature test. Sometimes people will talk about that as an integration test. It's a test where multiple pieces of your application are working together to accomplish a complete feature. The other kind of testing is a unit test where you want to test one thing in isolation. And the name of my talk is called Testing from the Outside In, because I want to start with this user story as the outside surface layer. And then as I write code to make this test pass, eventually I'm going to get to a part where I'm like, I don't know how to do that. I'm not sure what comes next. At that point, I pause this feature level test, and I'm going to write a new test that is inside of that is a smaller step, a smaller chunk of code. And once that test passes, then I go back to the larger feature test, and I continue my work. It's sort of like a recursive strategy for solving this problem. So that's the theory that I like to use about how to write tests for software. So I'd like to try a live example, and we can work on this together. I have a project that I've started up that's a really basic invoice thing. This is the end result that I want to get to eventually. I want to have an invoice on the screen that shows amounts and due dates and a total.
Can you move that up? People are in the back can't see.
Move which one up?
Only if the terminal is too small.
The terminal is mainly just going to be running the test and getting an error or a success. So don't worry too much about what you see in the terminal. I made I put checkpoints in my Git history so that if we get too far off track, I can just switch to that branch and we should have everything we need. But right now, when I run my test, I'm using RSpec. You can also use Minitest. This is a Rails application. I know a lot of you guys just started Ruby recently, but this testing works the same way. In general, you want to specify inputs and test the action and get the outputs. So right now we don't have anything. We should write a feature test. So I'm going to go down to my spec folder that RSpec uses and make a new folder called features. And we are going to add a new test. Invoices show name, date, and total. Spec. And there are different ways to name your tests and organize your tests. And it's important to be consistent so that people working on the same project have the same sort of test. When everything's consistent, you'll notice when things are different. And that's really useful when you're working on a team. So I'm just naming it after the user story that I'm about to write. That's the first step we talked about earlier. I need to get this test file set up. So I'm using RSpec, and we're describing some feature that's related to an invoice. That's a bad name, but we'll leave that name there for now. And if you were writing this test for real, you'd probably have a better one. So the first step was to write a user story. As a user, when I visit the invoice path, then I see, there's a business term I learned once. It's called the bill to name of the person who's actually paying the bill on your invoice. And I see due date, and I see all right. So like I showed you before, here's a description of a user going to a page and seeing a specific set of data. When I run that test, it immediately, well, somewhat immediately fails. That's a red in our red-green refactor step. Right now, the error that we're getting is that it doesn't know what invoices are, because I'm at square one. We haven't even told it that there are invoices in this system. So anybody want to suggest what the first thing we might want to try to do is in a Rails application?
Generate invoice.
That sounds like a great idea. Let's generate invoices. And we can see in the test that we need certain pieces of data on our invoice model. So what I see is on line 7, we need a bill to name. So I'll just put bill to, and that's going to be a string. On line 8, we need a due date. And on line 9, we need an amount. And you don't want to use integers for your, you don't want to use floats for your money, because then you get floating point errors. Just a tip. Decimal or integer are better. Okay. So we generated an invoice. Rails is very helpful. The people who are just learning Ruby may not have seen that before. Rails automatically generated a database migration so that we have a thing in our database and some code in the model for us. And we're going to run the spec again. And it failed because we need to migrate that migration. Excuse me while I clean up after myself. All right, there, the migration worked. All right, so now we have a passing test, technically. It's an empty test. It doesn't actually test anything. So we need to write some stuff some code up here in the test in order to actually check, is this happening? So we don't really need to get into defining what a user is versus an administrator in this specific example. So we'll skip line 5. On line 6, it says, when I visit the invoice path. Well, that's actually a command that comes from Capybara. You can say visit invoices path. And that just goes to the page that is at the end of that path. Now we expect that page to have some stuff on it. Expect page to have content. Let's say the first name is Foo Bars and Bats. That's an imaginary company that I'm billing. Let's just to test it thoroughly, have a second test on there. Anybody want to suggest a company name for the second company? I got one in mind. Widge. Where? All right. Next, we expect the page to have dates for these two invoices. The first one, let's say it's due on December 21st, 2017. And I picked that because date formatting can get a little weird. The month, day, year format is common in America, but computers usually use year, month, day. So I like to specify, I want to see this specific string that a human being is going to read on my invoice. I don't want to have like 2017 1221 6 T minus 7. That's the sort of thing a computer would be really comfortable parsing, but a human being would struggle with. So I'm defining a little bit about the format of my invoice by saying this is the string that a human being is going to read. And since I have two invoices, I'm going to do two dates. All right, again, we talked about defining the design of our page based on the test. So I'm going to say within the summary section, I'm going to decide now in advance that I'm going to have a div with that HTML tag called a div with the CSS class of summary, summary. And then that way when I get to it, I can style that class by itself and make sure that it looks pretty. But within that page, I want to make sure the page, or within that segment of the page, I want to make sure that it has the content let's say the total is $300. And I want to have a dollar sign, I want to have a decimal, I want it to look nice. So right now, there's something missing from these three pieces. We are doing a thing and we're checking the result, but beforehand we need stuff to be true about the world before this is going to work. We need data to exist in our test before that test is going to pass. So when we're defining the initial conditions of the world, we need to have two invoices, one that's going to this Foo Bars and Bats and one that's going to Widget Warehouse, and it has all this data that we're going to see later on. All right, so now we've got a test that successfully goes through that story of how the user is going to interact with our application, and it checks to make sure the things that we expect to see on the page are actually there. When they visit the path, they expect all this stuff to exist. When I run that test, I'm expecting it to fail. This is another good habit that you can get into when you're using tests to drive your development. When you run your tests, say, I expect it to fail in this way. At this point, we haven't defined anything about the Rails application, like the routes or the controllers or the views. So it doesn't know what this invoices path token is. So we need to go define that. If you've worked with Rails, you know that that's defined in the routes folder, the routes file. For the sake of simplicity, I'm just going to do resources for invoices. And now when I run that same test, it failed. All right, we're done. It's not working. Everybody go home. Actually, this is a really good thing. This is not failure. This is success. We have a different error than we had before, which means we're making progress towards a working application. Right now, what it's saying is we visit the invoice path, but there's no controller to handle that route. So it asked for the controller associated with it, couldn't find it. So I just have to real quick make that controller. Is it singular or plural? All right, cool. I got the single versus plural correct. Thanks for the help. So in our controllers, we have this file. We need to give it it's always safer to copy and paste when it's asking for that. All right, so we're just telling Rails this is where the controller is, and now we run our test again. And this is that red-green refactor loop in action. You run your test, we have a new error. Index could not be found. Now I know exactly what to do next. My brain is turned off. Not exactly. But it does take a huge burden off of your mind when you can let the test tell you what the next step is, rather than trying to struggle through guessing, using your intuition or your experience. You probably get it right eventually, but this is telling me exactly what it needs to see. New error, there's no view. It's missing a template. So the next step is just to make that view. Now when I run this test one more time, we expect a failure, but this is the failure that is the best one to get. This is a failure that says, I got this page, your page loaded, but it's missing the content you needed. So that's the content it wants to see. I'm just going to see what happens. I'm going to put it right there. You want that, I'll give it to you. Let's see. All right, new error. So it found foo bars and bats. It doesn't find widget warehouses. I'm not just going to copy and paste all the lines and get a static page that just has what the test is asking me to get, although that could be a good strategy to work on if you're not sure what to do next. Just hard code the answer now, and then once your test is green, refactor to try and get the correct or more versatile solution later on. But for now, I know that I know I'm working in Rails, and I know there are conventions. We should probably try and get an invoices object, some collection of invoices. We're using ERB, so we're going to put in an ERB tag, some iterator. And then for each one, let's just put okay, I have a list of invoices, so I should start with a list tag. Grab each list item. All right, so that should just be a list of every invoice and the bill to name for each person on it. And that's a lot easier than just hard coding the answer each time. But wait, we have a problem. Nobody defined invoices. And again, this is just leading me directly where I need to go. Let's go to it says we don't have that object. Where do we find it? Obviously in the controller. I mean, it's obvious to me, but that wasn't a very fair sentence. It may not be obvious to everyone who's starting out. But you should get used to declaring these variables in the controller because that's what its job is. For the sake of time, I'm just going to give every invoice to this variable so that when we get to the view, it just looks at all the invoices. In a real application, we'd want to scope this to make sure users are seeing invoices they're allowed to see, or invoices that are active and not paid. But for now, this is going to get the job done. Oops, typo. Great. So it now has more content on the screen, but it's, I think I missed an equal sign somewhere, and it's a little upset about that. But it should give us now an error that it doesn't have the due date on there. Yeah, it's looking for December 12th, 2017, but we don't have that yet. So we have that. We'll use the same strategy we had before. Invoice. Does anybody know what method goes here? There's a data attribute just called due. Is this going to work? It's probably not going to work. Does anybody want to guess how it's going to fail specifically? Sorry? You're right, it's not formatted. So I'm going to run this and just to see the error that comes out. And we have this 2017-12-21. That's really convenient for the computer to read, but we want the humans to be reading our invoices, so we want English words. This is a part where I would say, let's pause this feature level test and work on just getting the formatting of the date correct. So we're moving from the outer feature test inwards towards a unit test. In our spec, there's a really easy way to do that. You just say pending. And we'll make when we generated that model, it came with its own spec file. It's already marked as pending, and it doesn't have anything in it. So we'll have a new test that says it formats dates nicely. I didn't spell formats right. 2 T's? No, there's no E. Is that right? It doesn't matter, it's just the name. All right, so we need to test that the date model or the invoice model has some method on it that formats the date in a way that we like it. If you were doing this in real life, you would probably have a helper or a formatter. There's a different way of achieving this goal, but for demonstrating the way you would test in this strategy, I'm just going to put it on the model itself. You should separate the concerns of presenting data and holding data into different tools, but that's a different talk altogether. So we're going to have some invoice. This is the initial conditions of the system. We're going to create and I'm just going to stick with the same due date for consistency. Now we want to do a thing. So we're thinking of a method that would give us a nice due date for this thing. I'm going to say it's due on. It's due on some date. And that's the method I'm going to use to format this and make it look pretty. Then we are going to expect the formatted date to equal this date string that we wanted to see before. And right now there's no code that makes that happen. But we're asserting to the world, this is what's going to happen. We're going to have invoice.doOn do something for us. And then when we run the tests, we're going to see what do we need to do in order to make that work. And right now it says there's no method doOn. We didn't define it. So we need to go to the model and actually give it that method. And we can see from our test that right here, we called it with no arguments. So we don't need to give it an argument list. And its response, its return value, looks like it's going to be a string. So we need to think about how do we take that date object and get a nice string out of it. This is a part of the talk where I pull a little trick and I use some magic that's in the Ruby standard library. We have that do data object, that do attribute. We're going to use the datetime method striftime. And I've worked out earlier that this is what the format needs to be in order to get the thing we're looking for. And I'm sorry that that's kind of black magic, but it goes back to the C language when this formatting method was first created, and it's got a long history. But the end result is what we want. We now have a passing test. We've got that string formatted the way that we wanted it to, so now our human beings who are looking at the invoice will see what they need to see. So I'm done with the invoice model. I'm done with the invoice model spec. I'm going to get back to this spec that we were working on before. It's still marked as pending. I'm going to take that off, run the test again, and I think we're going to make some progress. We did make some progress. We have to change the view a little bit so that this method actually gets used, because we were using do instead of do on. Now that we've used that method, I think we'll see, yeah, we see a new error. So we made progress. We've got the due date in a human readable format. So the next error is asking us to make a div. It's saying that the specific error it says is unable to find CSS div.summary. So we need to make that on our page somewhere. I'm just going to code that in HTML and CSS really directly. And then in that summary, it's expecting to find $300, the amount that is totally due for all these invoices. So the way you go about getting that total is the way you would total up any other collection. All right, there's a new error. We've made some more progress. And this time, instead of not finding the amount at all, it says it found the amount, but it's formatted not correctly. There's another handy tool that Rails gives to us. We can use number to currency, and then just include this block of code. And that'll just change that number from $300 to $300. We did it. So this conclusion, what am I asking you guys all to do? Is it to just write a bunch of tests, just write 20 tests for every line of code you have? Not exactly. I do want you to write smart tests. Keep in mind there's two kinds. There's that high-level feature test where you try and make sure everything in your application is working together in the right way. And that could mean it's reaching out with API calls, it's accessing the database, it's doing all of these things that it's going to need to do. And the second kind of test is that it's testing very specific features, like that do-on method we defined, so that to make sure that the inputs and outputs for that work in a very specific way. Again, the consistency is really important. You want to make sure that if somebody else comes and looks at your code, whenever there's something different about one test, that is a message to them that says this difference is important. It's different for a reason, and not just different because I felt like writing it differently. I hope that that gets you guys on the right track with testing, and I really appreciate you guys listening to my talk today. If you have any questions, I'd be happy to answer them, and if you have comments on how I could do better, I'd love to hear those too. So your question is it better to write tests for a user's story, a user case, or for a specific method? There is sort of two different schools of thought on that. I think they call them something fancy in academic circles, like the London school and the Detroit school. But you can either start from the outside with a user story and work your way until you encounter a problem, or you can start at the unit level where you're writing for a specific method, and then once you've got all those methods working together, write tests to make sure that the two methods that interact with each other work together in the right way. So from the inside out. In my opinion, if you know a lot about the architecture that you're trying to get, and you've thought about all the details beforehand, inside out is probably better but it takes a lot of upfront knowledge. When I start working on a project, I will never know less about what I'm trying to do than at the very beginning. So I'm going to start with that user story, which I can understand, and let it guide me to the specific unit test that I'm going to want to do later on down the line. That's a good question. Thanks. Anybody else? Well, thank you very much for coming and listening to me. I appreciate it.